All right, welcome to the fourth episode of IT with Fatima. And today is Brief History of Computing Part 2. Welcome. And
Welcome.
after the last episode, we ended with Charles Babbage's analytical engine and Ada Lovelace. So we're continuing from that. So maybe we should start with the analytical engine first.
Yeah. So originally if you remember the difference engine, this was kind of the calculator by Babbage, and we need to remember that this was just designed. It wasn't really, built as is. So other versions of it were started to be built, but it kind of never completed until modern times, right? So there is one that is in the Science Museum that is complete, but that's modern, right? That it wasn't ever built originally. And the same thing was the case with the analytical engine, right? So the analytical engine was also a kind of a theoretical construct, a mechanical computer, and this was built, but like Babbage himself was only able to build a small part of the analytical engine, and then Babbage's son was able to construct again a part, and so on and so on. So here as well, the only final version was actually built in 1991, again by the Science Museum. So in this age, we have to remember that these engines, these were just ideas. They were not really running properly yet.
Right. But it was very detailed, the drawings and how it was written, how Babbage wrote about analytical engines. So it was easier to construct it in the modern times. And
yeah, definitely. So it was working like in theory, but nobody had kind of the time or the money to actually build it.
Right. So very exceptional. And Ada Lovelace contributed to the analytical engine by translating the text of a scientist called Luigi Menabrea and adding her own calculations to the translations. And she's known as someone who has written the first computing programming language.
Exactly.
Which is great. It's good that we have a woman who's kind of the mother of all of computer programming.
Exactly. So the text originally was a transcription of a lecture that Babbage kept, right? So remember, this was a theoretical concept. So Babbage would go around in different universities to give lectures on how this analytical engine could work. And this Menabrea wrote down that and published it in French. And Ada Lovelace then actually translated it into English and then added her own notes to it. And actually the notes are larger than the original text by this Italian guy. And here we can see a picture of that first algorithm. So this is how to create Bernoulli numbers. And this was the first algorithm written by Ada Lovelace as one of those notes added to the text. So it's not really a programming language yet here. It looks very math-like. But this is literally the first algorithm that has been written down to be run on a computer, even though the computer didn't exist.
Right. But pretty remarkable. Pretty remarkable. All right.
Absolutely.
Is there something we want to add about Ada Lovelace or Charles Babbage. They both contributed hugely to the field of computer science. So
Yeah,
Babbage was known as the father of modern computer.
exactly. Until now, all of the computers have been calculators, basically. And the analytical engine was the first computer that could do basically anything that modern computers can do.
So it was a
Of course,
theory of
yeah,
a modern computer.
yeah,
All right.
exactly.
Continuing forward to 1880s and Hermann Hollerith, who used one of the previously mentioned Jacquard's idea of the punched card system, which allowed the census takers to record all the information needed on punch card, which were then placed in a special tabulating machine with series of counters. And when a lever was pulled, a number of pins came down on a card. That was the explanation of this machine. And with Hollerith's machine, the 1890 census tabulation was completed in 1/8 of the time, and they checked the count twice. So this was again a step forward in the
Yeah,
world of computing.
find that one. Thomson's
And
or no?
it was a tabulating machine in 1890s, 1896. He found the tabulation machine company, which was
Yeah.
later was kind of like the father company of IBM, which we
Exactly.
now know today.
Yeah, I found it now. So
And contribution to the computer science was use of a punched card data storage.
yeah, kind of taking the mechanical calculators part that we already talked about, and then taking that Jacquard's loin part where we would use these cards to store how the pattern should work. So exactly, that's
Right.
That's basically the combination of those two.
Right. All right. And then forward, we take a huge step to 1939 and 1942 with ABC, which was found by Dr. I can't, let me. Dr. John Vincent Athanasoff. I'm not sure if I'm pronouncing that correctly. And Clifford Berry, who built the first truly electronic computer. And the ABC stands for Athanasoff Berry Computer, or ABC. And fun fact about this, Athanasoff said the idea came to him as he was sitting in a small roadside tavern in Illinois. Illinois, is it pronounced like that? And this was also the first computer to use binary math.
Yep.
And we'll
cool.
include the sources of the information, sources of my notes to this video, so you can go and learn for yourselves even more. So this was, yeah.
A quick note here. So this computer was not programmable, right? So it would do whatever it was told to do. And it's also, because of that, it's also not Turing complete.
So
Turing
it didn't,
completeness means that it's like basically a modern computer that we can use to do pretty much anything.
right. So this was the first electronic computer, but it still wasn't as the computers we're using now, but still a step forward. And then we're continuing into Alan Turing and Colossus 1. So Alan Turing was the father of the first successful electronic computer that was famous for breaking the code during World War III. World War II.
Not yet.
Thankfully, not World War III yet. So the turning the Russian code into
German.
English, German.
Yeah, so the
And
Germans, anybody who watched the movie remembers that the Germans used these Enigma encoders that were like practically impossible to crack. The code was impossible to crack by hand. So that was kind of the motivation for creating a computer that would be able to try all of the different combinations much more quickly than a human would be able to do. And that's kind
right.
of what Colossus is. Yeah.
So the computer was only there. It was capable for only doing one function, that was breaking the code, but still, it was basically the first successful electronic computer.
Yeah.
And then Alan Turing is also the father of the Turing machine, which really wasn't a machine, but a model of a general computer machine, a term made by Alan Turing. And in a sense of Alan Turing was a remarkable person in the field of mathematics, computer science, and also in human rights, noting that he was part of sexual minority. And there's also this law, the Alan Turing law. I think you can find it there, which was can you find the Alan Turing law?
Yeah.
There. So yeah, it's now used. It's an informal term for the law in United Kingdom contained in the Policing and Crime Act 2017, which serves as an amnesty law to pardon men who were cautioned or convicted under historical legislation that outlawed homosexual acts. And it's named after Alan Turing because Alan Turing was very famously convicted of then a crime of homosexual acts. So a notable figure in the field of human rights as well. And we honor him for that as well.
Exactly. So yeah, with Turing in general, he's done a lot of work with maths, so probabilistics, which was then used for those crypto decrypting those messages, and as you said, human rights stuff, but then also kind of information theory. So like you said, we have the Turing machine, which is this kind of complete theoretical model of how a modern computer works. We have the Turing completeness that tells us that a machine that is Turing complete can in principle be programmed to do whatever modern computers can do.
Then we have the Turing test.
The Turing test, exactly. That was what I was coming to. So the Turing test is this kind of hypothesis of how to figure of whether we can figure out by conversation whether we are talking to a human or a computer.
And it's still, we use that term still. This is the term we use when we are trying to determine whether we can recognize it, if you can recognize if a computer is human or not. So Turing has done and impacted a lot.
Yes, definitely. One of so like the Nobel Prize of computer science is the Turing medal, right? So
a remarkable person.
Yeah.
Thank you for your impact on the field of computer science, math, and human rights. All right. I think we could even have like an own episode of Alan Turing at some point because he has done a lot. Yeah, but definitely. Since this is a brief history of computing, we can now continue forward And next we're in 1944, Mark I, Howard Aiken, and Grace Hopper. So Mark I was the first electromechanical computer capable of making logical decisions. And the example of the logical decisions would be like, if X is 3, then do this. Not like, if it's sunny, I must wear sunglasses. So that's the example. And it was named after Mark Howard, so Mark I. And it was programmed by the means of punched paper. The instructions could be altered. And in many ways, Mark I was what Babbage thought analytical engine would be.
Yeah, just electronic instead of mechanical,
Right.
thanks to progress that had happened.
So what's I think notable here is the impact of people's ideas over and the evolution of those ideas over time. So it's useful even to have an idea or a theory of something and publish that theory so that people can work on top of that, which is great. Really, we can see the evolution of computing being as work that people have started and ideas that people have completed over time, which is great. And that was basically what Mark I was.
Yeah. And this is like Aiken exactly taking Babbage's idea and then making it real with the modern technologies that are available. And this was like done by IBM. So we have lots of people in here that make a huge.
We opened the term
difference.
IBM, or what IBM is, because I don't think we opened.
The International Business Machines. So originally kind of the TBM.
Yeah, originally tabulate. What was it? Tabulate.
Yeah, tabulating machine.
Tabulating machine.
And then we had the typewriters. So they did a lot of typewriters or other kinds of business, machines, mechanical machines. So that was there. And IBM, of course, we know it now well as a very large kind of computing company. And they always had a very good research department that came up with these ideas. But people who use this include people like Grace Hopper, nowadays Rear Admiral Grace Hopper.
Grace Hopper was pioneer also in computer programming.
Yeah.
She has done a lot. And one fun fact about Grace Hopper is that the word debugging is credited after her, since she was the founder of the first computer bug, which was an actual bug, a moth that was found in the blocking the reading of the holes in the paper. And these are the notes that Grace Hopper wrote after finding that moth. And it's funny that she actually included it. But yeah, this is where the word computer bug comes from.
Yeah.
But she has done way more remarkable things than this. This was just a funny fact about if you didn't know where the word computer bug or debugging comes. It comes from this. And what was great about Grace Hopper is that, yes, she was a woman. So back in the days, it was incredibly rare for a woman to be in the very male-dominated field of computer science. She not only was there, but like it's written in there, she was the first to devise the theory of machine-independent programming languages, and the Flowmatic programming language she created using the theory was later extended by others to create COBOL, which is still used today. So huge impact on computer science.
And in general, she had like double PhDs in mathematics and physics from Yale.
Right.
So she was a mathematics professor. And then she went
Navy Rear Admiral.
Yeah.
Huge woman.
She has like a warship named after her. It's like how significant. Let's see if we can find it.
Very significant.
Here.
Again, USS woman in the field of computer science.
Yeah.
That's great.
That one is named after her, right?
I think she deserves that.
And then we have other important people here as well. So one of the first users of computer is actually John von Neumann. And John von Neumann is maybe not as well known publicly, but a huge name in computers, specifically how modern computers work. So he created something called the von Neumann architecture that is being used in all modern computers. He might be better known from working on the Manhattan Project. So if you've lately seen the Oppenheimer movie, then you will see some references to his work in there as well.
And also, we're later going to be talking about quantum mathematics or quantum physics. So Neumann was a pioneer in building the mathematical framework, as it's written in there, of quantum physics. So
Yeah,
really a pioneer, since he has.
Yeah,
he talks about stuff that it's kind of exciting, or we view as exciting and new in nowadays, way before.
Yeah, so somehow pretty much everything he did made a difference in that field. Similar.
Again, if you feel like you haven't accomplished much, just go and read about.
So not exactly a polymath like Leibniz. So he's kind of more focused on mathematical applications, but still huge impact on stuff.
Right. Great people. All right. Since we have a theme of brief history, we're again continuing, even though every single one of these people deserve kind of like an own episode, like of their own, I think. So maybe in later times we will do something like that. But now we are moving forward. All right. Next, we have 1946 and ENIAC. So this was actually, when I was researching, ENIAC, how is it really pronounced? ENIAC. I'm not sure. But when I was researching this, I found out that it was actually programmed. There was a lot of women programming this ENIAC. So it was the world's first modern computer.
Yep.
And it was, the ENIAC stands for the electronic numerical integrator and computer, a massive computing machine commissioned by the US Army, which was a lot of this project. As you can see, Army was the technology that was researched to be used in Army or whatever Army basically. Is a lot of technology that it started as like an Army technology that we use nowadays. So like Grace Hopper and Mark I, the program they used, Mark I, and then we can see a theme here. So Army had played a huge role in developing the field of computer science. So a lot of women was involved, and also Black women. I found out Black women often tend to be not written in the history of inventions or doing things as we know. So what I really want to highlight here is that ENIAC wouldn't be ENIAC without women, and also Black women whom had played a role in this.
Yeah, I think the reason for this was that this is during / after the World War II. So it was kind of common to see women in kind of office jobs, like secretarial type of things. So programming computers was seen kind of as an extension of that. So it would be kind of a
Right,
job.
which is funny because nowadays we kind of feel, but yeah, it was seen maybe as like that. But the idea of new technology and inventions, it was very viewed as something that men lead. So women were often seen as kind of like the people who do the tasks, the repetitive things, and they were called cold computers. It's like people who complete the calculations, but the like exciting, inventing, taking the field forward, that was something that was seen that men do. That's something that men do.
Maybe
but it wasn't.
Yeah, sorry, just maybe just one short comment on why the army did a lot of the kind of financing of this research. So the army, in the army, artillery requires calculations on kind of, if you want to hit your target, you need to know how the ammunition will behave. And this is dependent on multiple things like the air moisture or pressure on different heights. So this is kind of difficult to exactly compute by a human being quickly enough to be used. So the computer was partially used for that kind of stuff. And then during the World War, of course, the military had basically unlimited amounts of money. So they could kind of put it in there. And we're still continuing to see that later on during the Cold War as well. So there's going to be similar situations happening.
Yes. So yes, what I really kind of, it's annoying to read about history and kind of like have to constantly guess how much of an impact women had and Black women had in the field, because we still to this day we don't know the true impact that women had, because but what was exciting,
we know a lot of individuals who had a big impact.
It's widely noted that the 6 programmers were women in this project. And what's interesting to me is that it says that that there were like lots of these like kind of degrading terms as sub-professionals, even though these were really highly trained mathematicians, experts in their fields, and in many ways probably more capable of doing these calculations and this programming than men were. So
yeah, it's maybe a sign of the times back then.
Right. Yeah, that was ENIAC. Imagine if we still had, or if we still use the term of people who do calculations, do math part as a huge part in the work as human computers. That would be interesting. Then I don't have much of notes on this one, but then we continue into 1948 and transistor. Where do we have that?
Yeah, in general, the transistor was built. Yeah.
Transistor. So yeah, in 1984, an event occurred that was to forever change the course of computers and electronics. Working at Bell Labs, 3 scientists, John Bordeen, Walter Brattain, and William Shockley, invented the transistor. The changeover from vacuum tube circuits to transistor circuits occurred between 1956 and 1959. And this brought in the second generation of computers, those based on these transistors. The first generation was mechanical and vacuum tube computers. So it was actually, it was very meaningful, since the kind of like hardware, this was a step forward in the hardware of computer evolution.
Yeah, so if we just kind of try to look at maybe the ENIAC, right? So this is kind of one piece of the ENIAC. It's very, very, very large.
Right.
These vacuum tubes, these would generate a lot of heat. So it would be actually very hot in there. And then they would break all the time. They would break like a little bit like your old lamps would. Like every now and then something would break. And then basically that means that the calculation that the machine was creating stopped. And then you had to go and fix it and then rerun it from the beginning. So very problematic. Then also a lot of this stuff was based on like physical relays. And this is exactly one of those places where that first bug went into. So you would have this problem of them malfunctioning every now and then bugs making trouble with your calculations. So with the advent of a transistor is like way smaller than a vacuum tube. You might know a vacuum tube from like a vacuum tube amplifier. These are kind of high-end nowadays, but it's like a reasonably sized piece of equipment, whereas a transistor is literally the size of the tip of your pen, right? So there's a huge minification happening here, and that basically then means that first of all, computers after transistors have been invented are way more reliable. And then they also become much smaller and they create less heat.
So huge step forward in hardware technology. Not so exciting maybe to your everyday learning, just a learner from the field of computers. But this was actually a big thing, as we know that if the hardware isn't efficient or if it's not capable of working properly, the computer the programs, the computing in itself is affected. So it's important, very important. All right, and then continuing forward, we go to 1951, and UNIVAC, which was the first practical electronic computer built by Eckert and Mauchly, and was known as UNIVAC, or Universal Automatic Computer. And the first UNIVAC was used by the Bureau of Census. The unique feature of the UNIVAC was that it was not a one-of-a-kind computer. So it was mass-produced. So this was kind of like a huge step forward into the world where we only had like a big computer somewhere in the back of university or army somewhere, which was only used by scientists, into a more of a mass-produced computers. And this way the computer came to your everyday person's life and usage.
Yeah, so still not to be bought in a shop, but you can see that we have a lot of installations besides just military installations. We also have large companies like Remington, General Electric, Metropolitan Life. It's a life insurance company, and so on and so on. And, it was still very expensive and very big, but people would more and more get acquainted to there being computers, right? Previously, the computers were a little bit hidden, whereas now people would be doing stuff like tabulating invoices using a computer instead of manually.
Right. And then we are continuing to 1954, IBM 650. It was the first electronic computer for business installed at the General Electric Appliance Park in Louisville, Kentucky. And in this year also saw the beginning of operation of the IBM 650 in Boston. And this relatively inexpensive computer compared to the very expensive, huge ones, gave IBM huge lead in the computer market. And over 1,000 over
Almost
1,000.
3,000 systems were produced.
Right.
So
that
here
was
you can see
that.
the kind of the size, right? So the majority of the size is like here on the left-hand side. This is just some storage area for printouts, right? So the actual computer is here in the back, and then on the right-hand side. So a lot smaller than those rooms that the vacuum-based computers were, and of course also much more powerful. And yeah, this is, I guess, the beginning of the IBM dominance of the kind of business computing world.
Right. And then we're continuing. By the way, we're gonna include all the notes. I'm using notes from
in the description.
Yes, we're gonna yes, we will include all the sources I'm using basing my notes on. All right, and then we are continuing into 1957, 59, IBM 704, and in the Fortran language was developed for this computer, and this time the state of art in computers allowed one component per chip, that is individual transistors. And then 1958, 1962, a lot of programming languages came up. Fortran, or formula translator, COBOL, which we mentioned earlier, common business-oriented language, Lisp processor, ALGOL, or algorithmic language, BASIC, beginners all-purpose symbolic instruction code.
That's the first language I learned.
Right. So 1958 and 1962 was also a time. What I want to mention is this was the time of the first space mission, or the first mission into United States, first mission into space in 1961, and this was the time of like the first big African American computer scientists, Katherine G. Johnson and Dorothy Vaughan. Vaughan. And where's my and Mary Jackson. So Mary Jackson was the first Black female engineer at NASA, and Katherine G. Johnson and Dorothy Vaughan were mathematicians, long careers at NASA.
This one.
You have it there.
Katherine Johnson.
Yes.
And then the other one was?
We have Dorothy Vaughan, and Mary Jackson. And Johnson, famous for calculating the flight path for the United States, or was involved in calculating the flight path for the United States, first mission into space in 1961.
Yeah.
So these three women, Dorothy Vaughan, Mary Jackson, and Katherine Johnson, were like the pioneers of Black women in IT and computer science. And what's kind of amazing to me is that they all worked during the laws, the segregation laws. So these were women who were in also already a kind of like a very male populated field, but also white men populated field, as Black women really killing it there, which is amazing. there's also this movie called Hidden Figures,
Yeah.
which is based on the book of
Margaret Lee Shetterly.
yeah, the untold story of the African American who helped win the space race. Margaret Lee Shetterly's book, and there's also a movie that's called Hidden Figures, which is telling a story about this woman. So yeah, Katherine Jean Johnson was someone who was already in the field of mathematics before she entered NASA, and then completed a long career in there. And Jackson was a maths teacher before going to NASA, or she had few other professions before that. And Vaughan was also a math teacher. So people who had long careers as mathematicians, and I like the term human computer.
Yeah, and this like I think Barry Jackson was the first Black female engineer at NASA. So really groundbreaking stuff, opening up careers for the next generations to fill in.
Right. Yeah, as someone who's a Black woman, I always try to look for the examples of people who look like me in this field, and I was very delighted to learn about these three women and their very extensive, long careers in very male and white male populated field during the segregation times, which is very great, amazing.
Absolutely.
I think we have to do a part 3 because we're already 43 minutes in.
Yeah, why not? This is maybe a good spot to break it and then continue with the next episode.
Right. Okay, thank you for joining. This was episode 4 of episode 4 of IT with Fatima. Episode 4 of IT with Fatima and Brief History of Computing Part 2. And we're going to have to do Part 3 because we are not in the modern times yet, but we're in the 1960s, and a lot has happened during 1960s and where we are now. So thank you for joining, and see you next week.
Till then, bye.